Okay, page 2 of the practice final. We've got vertical angles here, so they're congruent, which means 6x plus 13 equals 7x minus 7. If I solve that, I can bring the 6x over here, which leaves an x. Add the 7 to this side, which makes 20, and that's what x is. Here, there's two equations we make. If I want to find out what x is, it's vertical with 112, so that means that they are equal. If I want to find y, it's supplementary with 112. So I can make this equation. So to solve for x, subtract the 7, divide by 7, and we get 15. To solve for y, we subtract 112. We get 68 divided by the 4. And we get 17. So now we want to write an equation of a line that meets these conditions. So I'm going to be using this point slope form. This is my x1, y1. This is my slope. Y minus my y1 value equals my slope value times x minus my x1 value. Turn this to plus and distribute. And then add the 6 over. So I get negative 4x minus 14. If I want to go through these 2 points, I'm not given a slope this time, so I need to find it. So this is the formula for slope. So I'm going to take, and it could be y2 minus y1 also. It's arbitrary which one you decide to be x1, y1, or which one you decide to be x2, y2. So I'm going to take 10 minus negative 3, which is 13. Which means I have to take 9 minus 8, which is 1. So my slope is 13. Take y minus y1. It doesn't matter which one you choose. I'm going to choose this one. So y minus 10 equals my slope x minus 9. Distribute. Here we're going to get 117. Add the 10 over. And that's the equation of that line. Now I've got my conditional statement here. If a point is the circumcenter, then it's equidistant from the vertices. For the converse, I'm going to switch these parts. Okay, so it's going to say if a point is equidistant from the vertices, then it is a circumcenter. The inverse, I'm going to keep it in the same order, but just put the word not in. So if a point is not the circumcenter, then it is not equidistant from the vertices. contrapositive, we do both. So we're going to switch the order and put the word not in there. So if a point is not equidistant from the vertices, then it is not the circumcenter. Now, is the statement and its converse true? Well, the statement is true, because that's the definition of a circumcenter, or one of the properties of circumcenter. The converse is also true, because if we know that a point is equidistant from the vertices, then we know it's got to be the circumcenter. So yes, they're both true, which makes this a biconditional statement. In order to write the biconditional statement, we're going to take our hypothesis and conclusion and just write them down. So a point is the circumcenter. That's our hypothesis. Now, in between our hypothesis and conclusion, we put the words if and only if. And then we put our conclusion. It is equidistant from the vertices. All right, now we're beginning chapter 3, which has to do with parallel lines and the angles that they make when you have transversals. So I have two sets of parallel lines. R and S are parallel, denoted by these parallel symbols. L and M are also parallel with the different parallel symbols. So I need to find the measure of angle 6, which is here, if I know that this is 130 degrees. Well, if that's 130, I could say angle 3 is 130 because they're alternate. Nope, they're not. I could say angle 1 is 130 because they're corresponding, which makes angle 4 130 because they're vertical. And angle 4 and angle 6 are consecutive interior, so they're supplementary, which makes angle 6 50 degrees. Which lines are parallel if 3 and 6 are the same? Well, 3 and 6 are alternate interior on this transversal. So if this is my transversal, it's crossing line S and R. So those would be the ones that would be parallel. What has to be true about angles 4 and 8 for lines L and M to be parallel? Well, 4 and 8 are both sitting on this line, so that would be our transversal. That transversal crosses L and M. So 4 and 8 would be consecutive interior. In order for these to be parallel, our consecutive interior angles have to be supplementary. And that concludes page 2.